Hello, we're going to talk now about estimation of default probabilities. There are basically three methods to do that. The first one that we cover in this video is the simplest. We are basically just going to use credit ratings. The second method will be addressed in a video right after this one. It requires a little bit more work. And then the third method, which is the more demanding one, actually requires the use of Merton's model, so we will address that in a third video after we cover Merton's model. All right, so let's start. The first method again is the use of agency credit ratings. So as you know, there are firms whose job is to assess the credit quality of other firms. So these firms denoted credit rating agencies are these well-known firms such as Standard & Poor's, Moody's, and Fitch, among others. These three are the main ones. Together they have a huge market share, but there are a few more credit rating agencies that have a very small market share. So they assess the credit quality of a given firm, and the output of that work is a letter rating. So they will say that a given firm has a AAA credit rating or a AA credit rating or A credit rating and so on in this scale that you see here. Okay? So different firms have different rating scales, but there is more or less this equivalence that you see here. There's a significant difference between the top half and the bottom half of this table. The top half is denoted investment grade, the bottom half is denoted speculative grade, and the important difference is that some investors can only hold bonds with investment grade. Investors like pension funds, insurance companies, and so on cannot hold bonds of this lower kind. So once a firm decides to have a credit rating, it pays the credit rating agency to do the evaluation. The credit rating agency gives the letter rating, and from our point of view, if we want to estimate the probability of default of this firm, then our job is done. Basically, we just need to look at that letter rating and then look up one of these tables that the credit rating agencies output. This one is the one that Standard & Poor's output, and this gives us the probability of default. So for example, if we're talking about a firm that has a BBB rating, what this information here tells us is that the probability that a BBB firm will default within 1 year is 0.2%, this number here. So it's very easy to get the probability of default, like you see here. We can get the probability of default for any rating. And furthermore, we even have more information. We have all these transition matrix that you see here. So for this BBB firm, we know that it will default in 1 year with this probability, and we also know that it will change to CCC with 0.13% probability, to B with 0.56% probability, to double B 3.75%, and so on. So we have all these transition probabilities. How are these probabilities estimated? Well, they are estimated using historical data. So in a very simple example, like you see here, suppose that to make this as simple as possible, there is just two possible categories. Either the firm 1 year from now is alive in the state of survival, S, or it is in default. So how do credit rating agencies estimate these probabilities that you see here? Just by basically tabulating the transitions. So suppose that we start with 300 loans, and after 1 year we observe that 60 defaulted. So the transition probability would be probability of default 60 over 300, probability of survival the remaining 240 over 300. Given these transition probabilities for 1 year, we can do some interesting things with that. So we can compute probabilities of transitioning to a given rating category after a number of years different than one. So any n number of years. So how do we do that? We're starting with this transition matrix that we have here. Well, we have to do two things. First, we have to adjust for the fact that this column here, this column stands for non-rated. So in practice, it happens that after some years, some firms are just not rated anymore because the firms are not paying for the service anymore, or the firms disappeared, or for some reason they don't have a rating at the end of the year. So even though this happens in practice, we have to transform the matrix to get rid of that column. So what we do is we eliminate that last column by normalizing each transition by the number of bonds that do have a rating at the end of the year. So that will become clearer with this example here that I have here. Okay, and the second thing we have to do is to put one more row at the bottom for the default state. So for example, here, suppose that we have a very simple transition matrix like you see here, with just two states, A and B, instead of that big list of 8 states that we have in reality. Let's just make it very simple with A and B. And suppose that the table looks like this. The transition to A and B and default and non-rated, it's like this. So what do? We standardize the matrix to make it square like this. We get rid of this, we get rid of this column, and we add another row here. So for example, the number A here, the transition from A to A at the end of 1 year becomes 87, divided by what? Divided by the sum of these three numbers, 87 plus 7.9 plus 0.1, which is 95. The transition from A to B would be 7.9 divided by 95, and so on. So for example, the transition from B to A, this second number here, would be 10 divided by 84, and so on. At the end here, you would have a row of 0, 0, 0, 0, 0, zeros, and just 1 at the end, saying that default is an absorbing state. If you are in default now, you'll be in default for sure after 1 year. So I actually, I'm going to post the solutions to these problems. The problems are pretty easy, but just to make sure that everybody got the right numbers, you will see this file in Moodle with the solutions to these numbers, to these problems. This is the one I was just discussing. Okay, so that was the first step. We now have a nice square matrix, and the nice thing with this is that the n period transition matrix is just going to be the power n of this matrix. The reason for that is the following. So suppose I want to have a transition from say A to double A in 2 years. Okay, and here we're going back to the big rating scale with all the rating categories. So I want to go from here to here in 2 years, from A to double A. So there are many ways to get there. So for example, I can stay A for the first year and then in the second year go up to A, or I can go up to A immediately in the first year and then go up to double A in the first year and then stay double A, or I can go down in the first year to triple B and then go up a lot in the second year from triple B to double A, and so on, all these possible paths. So the probability of transitioning from A to double A in 2 years would be the sum of all these possible paths. So you can sit down and carefully convince yourselves that the sum of all these paths can be easily obtained by doing the power 2 of the transition matrix. Okay? So to make this clear in a smaller example, you have this small example here where we just have, again, 2 states, either survival or default, using the data from that example we did before. This probability here, let me go back to the solutions. So it was this matrix here that there was a probability of 80% of going from survival to survival, or 0.2 of going from survival to default. And then we add another row here in the end with default to survival 0, default to default 1. So to get the 2-year transition probability, I just need to do the square, the power 2 of the transition matrix. So if I multiply this matrix by this matrix, I get this matrix here. So for example, this number means what? This is the probability that the firm that starts in survival today is in survival 2 years from now. A firm that starts in survival now will be in default with a probability of 0.36 after 2 years. So, by the way, make sure that you understand what's going on here, and you can check that this is exactly the same number as we got in a previous exercise when we did these probabilities of survival and default with a simple tree. So the ratings are very convenient. If we have a rating for a firm, we can very easily get all these probabilities for that firm. The disadvantages are a lot. So even though people do this that I just said, this is a very weird case where the credit rating agencies themselves say that we should not be doing this. So if we go through their comments and their writings over the last years, you can then read this more carefully, but what you basically will find is that the credit rating agencies themselves say that we should not take their probabilities too seriously, and that there is obviously here a big conflict of interest, like I discussed here, which comes from the fact that the firm that wants to be rated is that firm that pays the service, that pays to the credit rating agency to issue the rating. Okay, I mean it did not have to be like this. Actually, many years ago it was a different model. So who paid the credit rating agencies were not the firms that wanted the rating, but were instead the investors that wanted the rating. But nowadays, for some reason, we converge on this model that it is the firm that wants to be rated that pays to the rating agency. So obviously, this creates a conflict of interest, and the credit rating agencies themselves acknowledge that there is this conflict of interest, and investors should be aware that their judgment is not objective and independent. Okay, I'll stop here and continue then in the second video.